Okay, let's go. Let's review a little bit. So, what you study in chapter 3 is a nomenclature. So, as you study, and I hope you also went over a little bit my videos about naming compound and nomenclature, and some substitution, substitutions that I cover in my other video in YouTube. Let's go over some example. Okay, let's do this. Pretty easy, but maybe hard. How about this? How you name this? So what's the parent chain? What is the parent chain? Wow. Okay, I'm gonna do my way, and then whatever you don't understand, you're gonna ask me in class tomorrow. Okay. So let's do my parent chain is gonna be 1, 2, 3, 4, 5, 6, 7, 8. I'm not gonna go the other way because make less decision. Is that correct? Let's do it. 4, 5, and 6. So make it 15. So let's try the other way. Try the other way. Try 1, 2, 3, 4, 5, 6, 7, 8. 5, 6, 7, 8. So this was better, right? 3, 4, and 5. So it's smaller. So we have 1, 2, and 3. We have purple. 1 metal, 2 metals. So it's gonna be what? Purple metal gonna be before purple, right? Because of alphabet. So it's gonna be 3, 4 di metal and dash 5 purple. Oh no, sorry, my bad. 5 what? 5 purple. Yeah, 5 purple. And what? How many carbon? 8 carbon. So with octane, right? Okay, that's octane. And let's do the other one. Let's try this compound. Try chlorine and bromine and alcohol. Without thinking, and you know that this is number 1, this is number 2, 3, 4, 5, 6, 7, 8. And see, we have 5 bromo and 4 chloro. And which one first? 4 bromo is gonna be first because B before C. So we 5 bromo and 4 chloro. Continue with octane, right? Octane 2O. Right, correct? And let's go try this. Let's try this. Try. This is pretty easy, right? This is pretty easy. So how do you name this one? You know, sounds to be what? Normally you're gonna do build to in, correct? But no, because whenever you see the bond alkene, you have to consider chains or cis as well. So is this chains or cis? And hydrogen right there, hydrogen right there. So the opposite side, right? The opposite side. One up, one down. So it's gonna be chains. So you need to do it like this. Chains due to in. Okay. Try. How about the bicyclic structure? This. How about this? That, and then just gonna do that. And how you know? I'm gonna wait. Just maybe that. Okay. So how you name that? name like this. You know what, from the left to the right, right? So you notice it's to be 3 on 1, right? 3 right here, 1 right here, and 1 right here. So just do it 3 1 1. And how many carbon? 1 2 3 4 5 6 7. So it'll be 7 carbon, so it'll be heptane, right? Not heptene, not heptide, because single bond only. So it'll be heptane. You have any substituents? Yeah, we do. It's number, where is number 1? This is number 1, it should be number 2, right? And then it's number 2, right? Is it number 2? Yes, this should be number 2. 2 what? 1 2 3 4. What, terbutyl? Is the butyl? It should be sec-butyl, right? Yeah, sec-butyl. It should be sec-butyl. Oh, sec-butyl. No, it should be sec-butyl bicycle. It's a butyl bicyclo. Yeah, it should be that. That should be it. 2 sec-butyl bicyclo 311 heptane. Correct? Yep. This should be for nomenclature. And let's go to the next. Okay. And what else? What else? What if a nomenclature is given and you have to draw a structure? For example, I'll give you this 5-methyl cycloband 2-eno. Okay, so you have methyl is a function, is a substituent. Cycloband, so you know, this is a 5 carbon ring. 2-ene, so the one in number 2 position. And O, eno mean 1 O, so O at number 1, right? So cyclo, so 5 carbon ring, right? O at number 1, double bond at number 2, and 5, so that's number 1 2 3 4 5 methyl. So that's the answer, right? Yeah. Okay, let's try I think it should be good for nomenclature. Let's go to the one more important. Okay, what if he give you a chair conformation and he want you to flip it and compare which one is the more stable one? Go to one example. I'm gonna give you one name. Cis 1 terbutyl 3 methyl cyclohexane. Okay, so first you have to determine the structure first. So what's the structure? Cis. Oh, you know, cis, it means one, like in the chair conformation, cis mean they both the same size. Okay, 1 terbutyl 3 methyl 2 substituent, and the cyclohexane is a chair conformation. So I prefer this one first. Okay, so I put this one at number 1 right here. 1 terbutyl. So just make it up. I want it up, right? I want it up. If I want it up, at number 3, which is right here, gonna be up as well, right? The methyl gotta be up too. And then that's it. 3 methyl cyclohexane cis. So what's the flip form? The flip form gonna be this, right? And this point right here is this point right here. This carbon right here is which carbon? This carbon right here, right? Because this one up, so this one had to up as well. But because we flip it, so this one had to flip too. It's equatorial. Third, right? This one flip become equatorial, right? And now which one you prefer? Which one is more stable? This one, right? Because this one have more equatorial. This one have axials only. What if another structure? What if I choose down? What if I choose down? Choose down. So in this carbon, down is equatorial, right? Down is equatorial. It look like axial. Oh. It look like axial. So put it like that. Okay, equatorial. And down right here is axial. And when you flip them, you flip like this. You flip it, still equatorial, but axial, right? And this one right here is a down. Oh, sorry, this one should be equatorial. And this one becoming axial, right? So which one more stable? This, because more equatorial, right? Okay, what if I change this 6 into a chains? Still the same, I pick this one. So this one up, this one had to down, be down. Down is axial, right? So forget about that. Down is axial, and up is this right here. That's a chains. And when you flip it, this one is equatorial. This one right down is axial, right? You can't tell. You can't tell which one is more stable than which one. Can you? Can you? You can. You can. This one is still the more stable one. Oop. This one is still more stable one because the one that equatorial more priority than the one equatorial right here. Just metal. This one is tubular. Yeah, more priority than the other one. Yeah, even though they have equal amount of equatorial and axial, but the one that have higher priority is still the one that more stable. All right. Okay, okay. You can say more priority, or maybe more it should be more molecular weight. Yeah, more molecular weight, not more priority. The priority only used for the R and S. Be careful at that point. Okay, what else should we consider for the test? Okay, remember C4A9 BR. For example, he gave you this one and how many structure. Okay, so we know that this is the alkane, right? Remember the diffusion something diffusion the DIH or DHI, I forgot. But if you remember this is awesome. Like a bromine and like a halide, bromine, chlorine, adding for one hydrogen. Like you plus one more hydrogen. And for oxygen, it's like 0 hydrogen, like you ignore it. 0 hydrogen, you ignore it. And for the one nitrogen, you subtract 1 hydrogen, right? So in this compound, you're going to transfer it into a C4A10, correct? Because the BR is a 100. Compared with the actual form, the actual form should be CN A2N plus 2, right? So it's the same, right? So C, because N is a 4, N equal to 4. So it should be alkane. Alkane, so should be single bond only with the bromine. 1, 2, 3, 4. We start with the linear structure first and move BR around that one first, and then this one, right? And now we try the one with the chain coming off. That would BR first, and then that, and then BR, and that's it. That is for C4. And what if he gives you structure like this? Okay, C588Cl2, this structure. And what you do, try to transform this one into a the one which is the carbon and hydrogen only. Gonna be what? C5H10, right? And try this C5H12, and then subtract C5H10, and how many hydrogen missing? 2 hydrogen missing, right? And you divide it by 2 like a formula in his lecture, you get 1. Number 1 right here is a deficiency hydrogen, I believe, DIH. Number 1, this number means the number of the benzene ring, of the ring or the double bond. Number 1, this number 1 means there could be one double bond or one ring. If this number is number 2, it could be 2 ring or 2 double bond or 1 ring and 1 double bond. That's what the number means. So in this case, you have 1. It means you have 1. You have there could be 1 double bond or one ring, right? So they give you C5. So try the double bond, right? You try the double bond, C5A1, C5A8CO2, 1, 2, 3, 4, 5. 1 double bond right there. 1 double bond and 2C. 1C, 2C. Is C5H, 3 hydrogen, 4, 5, 6, 7, 8. That's the first case. The second one, you move the chlorine, move around, and you can move the chlorine over there, over here, chlorine, and then you move chlorine to over here, is a lot. And then try other structure, 1, 2, 2, 5 over here, and try move 2 chlorine over here, chlorine over here, chlorine over here. And not to forget the stereochemistry, the wedge and dash. For example, this case, this case, you have two cases. One is a wedge, the other one is a dash. Or you have this one is a wedge, and this one's a dash. This one dash, this one is a wedge. Yeah, different case. And how about the ring? The ring, right? The ring. You know, one ring, so there could not be another double bond, right? One double bond or one ring. So now this is a ring, so not double bond. One case, chlorine. It is compound chlorine. These two chlorine could be wedge or dash. So you don't have to put this one wedge and this one dash and this one dash and wedge. They're both the same. So you don't have to just align. Another case, another compound. This is right here. Here, chlorine. That one or this one, right? Or you can do that. Or you can do one up and one down. One down. Yep. You squeeze that into here. Right here. And right here. Yep. And then put one dash and one wedge. And then it wedge and then dash. Okay. Okay. And next is for the Neumann projection. For Neumann projection, as I discussed in class, it's pretty hard for me right now to discuss in such a screen right now. It's hard for me to explain in the screen. But we can go to specific example. We can try the example. For example, this Ca3 H chlorine H. So this is given, and you have to give him the bond line structure. So this is the bond line. You know this is the first carbon, right? Second carbon, third carbon, and the fourth carbon, right? And you want to look at this way. So the front carbon gonna be over here, right? And the back carbon gonna be over here. And see the front carbon, the Ca3 right here is going up. So you will have one thing going up, the other thing going down. These two connect together. So you have 4 carbon. And you notice chlorine, hydrogen. When you flip it, you flip like this. You can flip it in like this. This is you. You look at this way, right? You go this way. So you look at toward the screen right here. It's like you look at the screen right now, and then you turn your body to the right. You turn your body to the right, and then you will have this molecule like that. This is the point that you're looking at, and Ca3 right here. And then when you flip your body to the right, when you rotate your body to the right, the chlorine they're gonna go inside, and the H chlorine right here gonna go inside, and the H right here gonna go outside. So you have chlorine go inside and hydrogen go outside. And after you determine the first carbon, the front carbon, for the back carbon, whatever on this side, the same side, they both have the same wedge or dash. On the other side, they both have the same wedge or dash. So chlorine here is a dash, so hydrogen right here is a dash too. Hydrogen right here is a wedge, chlorine right here is a wedge too. So now you have this one, right? And now to determine the stereochemistry R and S. R and S is pretty easy if you try to simplify it. So it's easier for you. It's better if you draw the simple structure first, like this. This is like this. That. This is connected to the other group, which is this group right here. This is connected to the other group, like hydrogen right here, one group and other group. It's like that. This is just a simple form. And after that, you number it. Chlorine should be number 1, so number 1 right here. And which one number 2? This is number 2, right? So it's number 2 right there. And number 3 is the carbon Ca3 right here. And number 4 is right here. Here you see as number 4 is in the wedge. We don't want it. We want number 4 is in the dash, so that we can eliminate eliminate it, and it's easier for us to see is RS. So number 4 is a wedge. So look, try to find a dash and squish that with the dash number. Now you see number 4 is a wedge, and you see number 1 is a dash. So switch that with number 1, and when these two switch, 2 and 3 have to switch as well. So you will have this number 4, number 1, number 3, number 2, and now number 3. And now you can ignore number 4. Now you just need to draw an arrow from 1 to 2 to 3. 1, 2, 3. That's R. Alright, right? So this right here is to be number R. Right? And how about the other stereochemistry? Just redraw it. Okay. Now you look at this carbon. Draw it out. Draw the symbol form. Right? And then chlorine is number 1. Hydrogen should be number 4. And this thing right here is the number 2. And this is number 3. Now number 4 is already in dash. Now just simply forget it. Ignore it and then draw the arrows. 1, 2, 3. It should be S, right? So the stereochemistry right here should be S. Okay. Okay. Let's go to different problem for pyrolysis center. You I think it should be fine for y'all, but just go to one example. This. So which one you believe is a chiral center? I believe this one right here, because this one connect to different group. One different group. This is 2 different group, 3 different group, and then the hydrogen right here, which is the 4th different group. So this is the chiral, right? And now we look at this. We look at this carbon right here, which is not chiral because we have two same group, like the hydrogens, right? So it's not chiral. How about this? They are symmetric. So when you try to look at this carbon, only one different, and other 3 group is ethyl. So they are 3 the same. So this one should be a chiral, right? And this, the one right here, should be chiral. Correct? Okay. And we finished the chiral center. Now goes enantiomer and diastereomer. Again, when you compare RR to RS, to RR is the same. SS to SS, put it the same right here. It's still the same. When you have for RR into SS is enantiomer. When you have for RS to SR, this is different. 2 case, you have to rotate. You have to rotate things around to get it enantiomer all the same. You have to rotate the compound. Okay. Let's go to example. For example, this I'm gonna do hydrogen, chlorine, chlorine, hydrogen. And this one is, I'm gonna make this one is a chlorine, hydrogen right here. It's chlorine. Put this exo, this is exo hydrogen, and equatorial chlorine, right? And after the determine, I got this one is the R, this one is the R, and this one is a S, and this one's S. Now you have RR to SS, so it has to be in enantiomer, right? And how about this? Versus this. Right? Now this one is the number 1, number 2, 3, and 4, and now you flip it, right? Because it is number 4. Because this one is number 4. We don't like it, so switch number 1, 4, 2, 3. So it's 1, 2, 3. So this one is S. How about this? Number 1, number 2, number 3, and number 4, right? Now it's a dash. So how we squish it? Squish with the number 4, right? Number 4 was a dash. So this is number 4. This is number 1. This is number 3. This is number 2. Now forget number 4. So wait. Now forget number 4, which is right here. Sorry. So now is a 1, 2, 3. So it's an R. So when R combine R S compared with the R is enantiomers. Okay. So R has to be easy for you. And for the SN2, SN1 reaction, I know what I'm gonna tell, but let's see, that should be all for this review. And if you have any question for SN1 and SN2 reaction, come early tomorrow, ask me. Thank you.